found it interesting. I'm now going to go off into a bit of what might seem a tangent and look at the whole singularity, transhumanity thing, which I sometimes call humanity 2.0. Not very originally, possibly. So, one of the ways technology tends to get adopted is it just happens. So, in this particular case, CCTV in the UK, as an example, you're meant to be filmed 70 times when you walk around London every day. No one ever agreed to that idea. The politicians didn't pass laws. The people, we the citizens, didn't say, hey, we think these are really cool things. It just kind of grew up and happened. This is an example from a couple of years ago of an unofficial police initiative to log number plates as we were going along the motorways. Again, there was never any discussion about whether this was a good thing for society or whether it was a bad thing for society. It just sort of happened. Again, another example would be the whole idea of using camera phones or cameras in phones to the point where it's incredibly intrusive, particularly for celebrities. I mean, one of the reasons why David Cameron cut it short his recent holiday is because everywhere he went, as well as the paparazzi, people going taking photographs of him, including the people who broke the story in the thing. And again, I'm not saying it's a good thing or a bad thing. I'm just giving it as an example of how technology happens without any discussion. And it's the same with the singularity, which we're doing. Another example is the Chinese government decided to bug all the taxis in the last Olympics. Again, you know, no discussion, no real controversy over that. If you were a tourist, you get bugged, and that was China, you know. Also, you know, the controversial Mark Zuckerberg constantly changing the definitions of what he thinks should be released out to the general public rather than your private data. He's constantly shifting that balance, and again, he doesn't ask us, he doesn't even have a sort of like a committee of users. He just decides that he knows best and does it. So technology isn't very democratic as it happens. There's a couple of reasons for that, one of which is we don't vote on those sort of things. We vote on a representative democracy. We put a guy into parliament or whatever, and he represents us even though he might not understand the issues very well. They don't tend to debate them in parliament or in any form of representative democracy, because again it's sort of not something which ever appears on their agenda, and partly it's because of gentlemen like this guy who described, he's one of the senators in the States who actually died in a plane crash recently, but he described the internet famously as a series of tubes, which he thought was going to be a kind of cool way of explaining that he knew what the internet was, but in fact it obviously demonstrates that he didn't know anything about it at all and was completely ignorant. So when you've got people like him who are trying to understand the implications of technology, it's a very, very worrying situation, and it's not going to get debated effectively in Parliament. So this is where we come on to the explanation of what the singularity is and what the next big thing in terms of breakthroughs in our society is going to be. The singularity wasn't invented, it was popularized by this guy called Ray Kurzweil, and Ray also founded the Singularity University, which I was talking about earlier on, he didn't invent the term, but he certainly has popularized it, and he's got a new film out about his life called Transcendent Man, which is certainly worth having a look at if you're interested in this whole area. And I'll try and explain what the singularity is. It's just have to understand that, really. So what the singularity is, in popular parlance, I suppose, is when the machines take over. That's what the definition of singularity is. So we're talking about a time at some point in the future when the machines will run, or PCs, computers, call them what we like, will actually take over the world and run it for us. Why is that likely to happen? Well, you know, the idea of that ever happening in conventional terms, in linear terms, of us inventing a computer which is powerful enough to ever do that, is pretty remote. We don't have the resources or the ideas to be able to do that. But what we can probably do is create the first computer which will enable the next generation computer to get better and better and better. So in other words, once you've invented a computer which is capable of inventing another computer, you will suddenly find that the progress of this thing suddenly gets exponential rather than linear. And I'll give you an example of what that might be in terms of, we're not very good as a species understanding exponential technology, i.e. some stuff which is growing really, really very quickly. And a good analogy of that, of exponential as opposed to linear technology. Linear is like, I know I can walk to that wall in about 10 yards, and we're quite good at understanding that, or that the House of Parliament is 500 yards over there. That's pretty easy, and that's how we tend to think as a species. But when technology suddenly starts exploding like that, in other words, exponentially, we're not very good at understanding. So a good example of an exponential growth would be somebody walking onto this huge stadium pitch and putting a little drop of water, one single drop of water, on the centre spot at sort of half time. And if that drop of water doubles every minute, and you're right up here, right at the back, how long do you think you have before you drown when the water's doubling every minute? And our kind of primitive brains tend to think, wow, it's going to be like years, months. But in fact, the answer is 46 minutes. And that's sort of like, ooh, that's rather quick to drown from there. But the interesting thing is, because of the way technology works, is that most of the growth in the early stage is very, very unnoticeable. So most of the water is actually flooding the pitch actually below the turf, so you can't really see it happening. And suddenly, with about 5 minutes before you die, you see a little bit of a puddle here or there, and then a bit more, and then it's halfway up, and you've got precisely at that point a minute to evacuate the stadium before you drown. And that's how fast technology is coming through. And if you think in the last few years about mobile phones, if I'd said to you 10 years ago that actually everybody in the world practically would have a mobile phone, and they were this big, and they'd hold 1 billion times better computing power than the most powerful computer 30 years ago, you said, no, you're mad. But that's the point about exponentially growing technology. It does seem as nothing's happening, and then suddenly it starts to build. And so, from that perspective, sorry, go on.
Sorry, I may have missed something, but like in the example you just said, that's not sort of computers programming it, that's us using computers.
We invent the first one, the first computer which is sort of sentient, and which we invent in maybe 5 years' time, which will enable it to invent another computer, which will invent a faster computer and a faster computer. We're sort of starting to get there. That's the point. But once the machine can invent another machine, then you'll see it going like that, and it'll be absolutely. So, what does that mean? Well, the thing is, when you're talking about exponentially growing technologies, nobody actually knows what it's going to mean. Because you're talking about a machine running the world which is maybe 100 million, billion, 2 billion times more powerful than us. So it's like an ant trying to kind of figure out what a human's going to do next. But there's a number of different scenarios which could happen, and might not, but I'll just talk you through those. One of the themes is certainly the idea of man and the whole thing about transhumanity is actually merging with machines in some way. Now, we're all cyborgs up to a point. We all wear shoes, we all wear clothes, a lot of us wear glasses. So the technology, the idea of using technology to enhance our lives somewhat is pretty much there. A lot of people already have pacemakers and things like that, but as you can see in the next few years, as some of the emerging technologies happen, we may merge more and more with machines to make us actually completely unrecognizable as people we are today. For instance, they're talking about nanobots which will go into our blood and replace some of the corpuscles, and this is going to happen in the next sort of 10, 15 years or so. And will sort of perform routine checks and kill cancers and clear you out and make sure you live a healthy life, kind of thing. And I know it looks, I know it seems puzzling, but you ought to remember the exponential growth of where we are at the moment. At the Singularity University, as an example, I saw a man who was paraplegic walk into the lecture room in an exoskeleton. That would have been unconceivable a few years ago, but that's an example of how quickly medtech is going at the moment. So that's one scenario, we might merge the machines. Another scenario would be the fact that actually the computer thinks that a much better solution would be, rather than living here, that we actually digitize our brains and go up into the cloud, into a sort of augmented reality up there, where it'll essentially be indistinguishable from the real world. And this is due to happen in about 2045, by the way. So if you're kind of like in your 30s and 40s, chances are you probably see it happen. This isn't like a 200-year scenario. This is something which can happen in our lifetime. And the technologists who are sort of running this, and there's like a bunch of them, maybe 50 of them who are going to influence this, and who are working on the AI programs out in the mainly in San Francisco area. So hey, don't worry, we're going to program the computer. It will be really nice to us and be really cool and everything. They sort of sometimes cite these 3 laws of robotics, which Isaac Asimov, who's actually a science fiction writer, came up with, and basically it says that it's not allowed to harm us, so it's going to be really good. But having said that, again, I come back to my analogy of an ant. Are they really, these machines really going to say do what we tell them to once they're that much more powerful? I don't know. So the people who say that this is going to be a great thing, and I'm probably one of them, because at the end of the day, the alternative to these kind of scenarios is that we're all going to die, and who wants to die, is that this will be a sort of heavenly place to hang out. It'll be the end of wars, because the computer will make sure that we're not going to be fighting each other. There won't be famine. It'll be a time of everybody's going to have to eat, because at the end of the day, if you're living in a cloud somewhere in a virtual world, you don't need them to eat. You'll get your nutrition some other way. There'll be no more terrorism. Actually, no more work. No more death. I mean, you don't need to die in this world. And in fact, one of the interesting things is using the DNA of kind of some people who are dead. You could probably recreate some of your ancestors as well if you want to hang around with them. And in some ways, one of the interesting things about this is that the kind of creating heaven, as it were, is a lot of kind of religious parallels to this, in the sense that in some ways it makes it quite easy to sell, because it basically gives everything people want. But there are some downsides to it. The first one is quite nicely illustrated by this book, about 20 years old or so, called The History of the World in 10.5 Chapters. And the scenario is that the guy dies, and he goes to heaven, and the first day he's greeted by this very attractive lady who says, "What would you like to do today?" And he says, "Oh, well, I think I'll play golf." So he goes to St Andrews magically and has the best round of golf he's ever had in his life. Fantastic. Goes back the next day, has an even better round, and after a couple of weeks he's sort of getting a hole in one on every hole. So he thinks of more exotic places he can go, and then he thinks, well, who haven't I ever met? I would like to have dinner with Napoleon. So he has dinner with Napoleon, etc., etc. After many, many years, unspecified number of years, he's done really everything he wants to do. So when the nurse walks in and says, "What would you like to do today?" he says, "Can I die?" Because ultimately, if you're living for that long, isn't life going to get unchallenging, boring, etc.? You can always decide to go to sleep for 15 years or something if you want to, but there is that downside to it. The other possible downside is obviously popularized through some science fiction, which is the Terminator scenario, where the machines decide actually they don't want us to live anymore, and they're going to kill us all. In much the same way as we would kill a mosquito today, or wipe out mosquitoes, which we're planning to do in certain parts of the world, because they're just an irritant. If that super intelligent machine, they may not wish to have us around. Another scenario might be, well, actually, we better look after these people because they did create us after all. Let's see what happened last time they were asked to look after other animal species. We've got the battery farms or the other sorts of farms which kind of give you some kind of existence but not very much pleasure in life. And obviously there's also the idea of them just using us as some kind of fuel system, which we saw in the Matrix 2. As far as promotional marketing is concerned, well, I think the kind of message here is that we'll be in a post-scarcity economy by that point, so we won't need to work, no one will need to buy anything, so we'll all be out of a job. Thank you very much.